How are you doing today? So, because I know this is your third time around doing exponentials and logs, we're going to hammer out two lessons today. We're going to talk about the properties of logarithms, and then we'll go ahead and use those properties and some other things to do some solving today. So, real quick, just to refresh your memory on the log properties. So, we have what we call the product rule. And so, anytime you're taking the log, it doesn't matter what the base is. If you're doing a log of two things multiplied, you can actually expand that out into the sum of those two logs separately. Okay, the bases will always have to be the same, and they will be. We're not going to get tricky. Okay, if instead we're taking the log of two things being divided, well, you could separate that and expand it into two logs that are being subtracted. All right, and then the one other one is the power rule. This one says that if you're taking the log of something raised to a power, that power can actually just come out in front like this. It used to have a P here, now we brought it out front. I think it's kind of important that we just don't throw formulas at you and you just like accept them blindly. But ultimately, what's happening right here, this is like a log. I'm just going to do a common log of m to the, let's pretend it's m to the third. So it's m times m times m. Okay, that'd be the equivalent of an m to the third power. But then what you're really doing here is you're taking this and you're using your product rule. If I am multiplying these, then I can separate them into individual logs that are all being added together. But here's the thing. Would you really go through the process of taking log of m plus log of m plus log of m? Or would you just take the log of m and just take it times 3? Yeah, that's where that's coming from right there. And you don't have to memorize that little trick. I just want you to know there's a reason, method to the madness here of where that's coming from. So let's practice using those properties. We're going to start with some expanding. Anytime you see everything clumped together into one big like logarithm with a bunch of stuff, we want to expand that into parts. All right, so what I see happening here is I see multiplication and more multiplication, but I also see this 3. But notice that's an exponent, but it's only on the x. So I'm going to separate this into the addition of several logs. So it's going to be log base 4 of 5 plus log base 4 of, and I could write x cubed, but what do you think I'm going to do with that cubed? I'm going to bring it out in front, but only on this one log because the cube was only on the x, plus log base 4 of y. Okay, not really, I mean, you can show some work, you can do this in steps, but I find that some of you have done this enough and you can do that mentally, so that'd be great. Okay, got us a really crazy one here. Look at that mess. Okay, so what I am seeing is I see this power happening with an x to the 4th. I see multiplication. I see a square root of y, which really is just a y to the 1/2 power. So that's actually just an exponent. Then I'm dividing and I have a cube root. Okay, I got a mess of stuff. Here we go. Log base 7 of. All right, so I have an x to the 4th. But what I'm going to do is I'm going to go ahead and pull that 4 out in front here. And then it's being multiplied, so I'm going to add. And then I have a log base 7 of a square root of y. But instead of a square root of y, I'm going to think of it as a y to the 1/2. And instead of writing y to the 1/2, I'm going to put the 1/2 in front. Okay, now I'm going to do division. So that means I have to subtract log base 7 of, okay, well, I see a cube root. And it might be tempting to try to do something with this stuff in here. You can't. You really can't do anything with that. It's the cube root of that quantity. So I'm going to sneak. I should have given myself enough room. I wasn't planning ahead enough there. There's a 1/3 in front because it's a cube root. And then you have to put in parentheses because all of this was being cube rooted. If you don't have that in parentheses, that would get counted wrong because all of it was cube rooted. Keep it in parentheses. And then there's no way to really expand on something with addition. The addition happens when there's a log on both of them and it's being added. Like up here, when you're adding 2 logs. That's not what this is. We're done. That's all you can do. Now, the reason for the expanding is to allow us to do some reducing. So now I'm going to introduce that idea of let's expand it and then let's reduce anything that will reduce. So looking at this one, I have a log. So I'm going to scooch this over here. Log. It's a 1/4, and it's on both of these things, but this is being multiplied. So I'm going to change it to addition, but I'm going to put a 1/4 on both of those. So it's a 1/4 log of 100 plus a 1/4 log of x. Now, this one over here has an x in it. There's nothing I can do, but this, I should be able to simplify this. And I mean like in my head, not with a calculator. Because a log, ignore the 1/4 for a second, you should be able to find the log of 100. Remember, common log, 10 to what power is a 100? 10 to the second. So this is 2 times 1/4. That's 2/4. That's 1/2. So this is ultimately a 1/2 plus 1/4 log x. Okay, let's try our next one. This one has division going on with it. So this is a log base 3 of 27 minus, and again, a log base 3. And I have this big square root, so I'm going to put it out in front as a 1/2. And since everything is square rooted, I've got to put this part in parentheses. All right, that part over there is as good as it's going to get. It's got the variable, so nothing else I can do, but this is something we should be able to do in our head. 3 to what power is a 27? That's a 3. All right, there we go. Now let's try some condensing. So that means that you're going to have some of those things where you can condense it into where you just have the log of one thing, but that one thing might be kind of big. So in this first example, really this 4 out in front is considered not condensed. I'd rather not have that coefficient. If I'm trying to condense, I'm going to bring it up as a power. So really what I want to do here is I want to write this as a log of x minus 3 to the 4th power. That would be considered condensed. Do not feel like you have to actually do that to the 4th power. We're just going to leave it. Okay, next one has a little bit more going on. This 1/2 is going to have to come up as an exponent. It's going to be a square root. This minus is going to turn into division. So I think what I have here is natural log of a big division problem. I'm going to have this square root of all of this, and then I'm going to have a y in the denominator. Now, I know some of you are really, really, really wanting to call this x plus 2. Okay, you cannot square root like that. When you have addition happening here, you can't just suddenly square root each of these. It's the square root of the sum, and since we don't have the sum, we can't square root it yet. You're done right there. Can't do any more. Right, so these two are for you to practice, see what you can do with these. Go ahead and pause the video, come back when you're done. Okay, so here's what I've got. Couple things that were quirky here. I mean, you can check, and if you've got exactly what I've got, I guess go ahead and move on. This here, though, I feel like some of you might have chosen to bump that to the denominator because that's what you do with negative exponents. Maybe you rewrote that, but when you bump it to the denominator, that means you're now going to be subtracting it. And that's what I ended up doing by just pulling my -6 in front. So either way, we should get to the same answer. This one, though, this right here, I tweaked this. You might even be able to tell I kind of edited that. It is important to recognize, just like up here, the only thing that would have gone to the denominator would have been the y. The z is up on top. Same thing happens here. This minus sign is only affecting this term. This is the only part that's going to go to the denominator. This then ends up back up to the top. Let me think, what else do people goof up? Oh, it's not like a log on the top and a log on the bottom. It's just a log and then one big mess of stuff going on after that. All right, let's keep moving. Now, from here on, we're going to do some solving. And those properties are always going to be fair game to use as we do some solving. But we also will want to be switching forms, and we have all these methods that we can do to solve. So the first scenario I want you to try is to do solving using the one-to-one property. A one-to-one property can be used with exponentials. It can also be used with logs. On exponentials, you want to write both sides so that they have a common base. And that base needs to be a whole number. So I wouldn't want to use 1/3 as my common base. I'm going to use a 3 as my common base because I know the 1/3 and the 9, 3 would work great. So what I'm going to do is I'm going to rewrite my 1/3 as a 3 to the -1. And then it's also being taken to the x power. I'm going to rewrite my 9 so that it's a 3 squared. So what I've managed to do is write these both with a base of 3. If you can get these to both have the same base, then the only way this side can be equal to this is if this exponent is the same as this exponent. So what you do is you just forget the 3's and say, all right, well, so I know that the exponents are going to have to be equal. So -x is going to have to equal 2, which means x is going to equal -2. That's how you do a one-to-one. It doesn't always work, but it's pretty quick, a quick method if you have numbers that could be written with that common base. All right, we also can do a one-to-one with logarithms. If you can make a log equal a log, you have one log on the left side, one log on the right side. Okay, so in this example, I have 2 logs on the left. So what I'm going to do is I'm going to take this log and I'm going to move it to that side by adding it. So now I'm going to do a couple things here. No, I won't. I will take it slow since this is notes. I'm going to add that over. Okay, next thing I want to do is I want to condense this. So remember, I don't like the 3 in front. So what I'm going to do is I'm going to take it up to the top. So I'm going to call this log base 3 of x cubed equals log base 3 of 8 squared, which is a 64. All right, at this point, I've got myself a one-to-one situation. I have a log equals a log, same base. Again, not trying to be tricky, that will always be the case. So when you have a log equals a log, the only way that can work is if this piece and this piece, the arguments, remember those are called the arguments, the only way these can be equal is if the arguments are equal. So I ditch the logs and I just look at the arguments and set them equal. All right, cube root both sides. So x must equal 4. Okay, again, one-to-one properties, pretty quick, nice methods. If you can't do the one-to-one property, then you're probably going to refer back to the switching forms that we practiced yesterday. So looking at this one, I'm trying to solve for x. So this is a common log, so I know there's a little 10 here. So 10, if I were just to ask you, if that's a 10, what do you think this x is? And how many of you think 2? Yeah, right? It's not. I probably meant for it to be, I don't know, but it's not. It's a 10 to the 100 equals x. So this is not going to be a 2. This is a 10 to the 100, which is a crazy huge number that I'm just going to leave as is. Okay, let's try this next one. This is assumed to be a little e, so I'm going to switch forms to isolate the x. It's an e to the third is equal to x. Now, e to the third, typed it in my calculator, I've already done the math for us, is 20.09. Okay, now those were both logarithms and I switched them to exponentials. Now I've got some exponentials and I've got my unknown caught up here as the exponent. So to get it out of there, yesterday, if you will recall, we put this in y1, we put this in y2, and we found the intersection. All right, yes, that is a great way to do it. Well, I say it's a way to do it. I don't know if it's a great way. It's time consuming. We can do this by solving we can solve this by switching forms. Now that we've talked about that switching forms and we're better at it, then we should be able to switch this to a logarithm. So this is a log base e, which I'm going to call natural log of 7 equals my exponent. Now I've got the exponent, or the x, isolated, and I can just type in my calculator the natural log of 7, and I get 1.95. Okay, on this next one, I think I would like to isolate that x, but I think the first step needs to be get that 4 over on the other side. It doesn't need to be there with the 3 to the x. So let's add it over here, and now I'm ready to switch to a logarithm. So this is going to be a log. The base is 3 of 6.5 equals my exponent. I typed that in the calculator, and I got a number that I don't think is correct. Oh, you know what? I need to talk about this anyway, just in case you don't remember. How do you type in a logarithm if it's not common log or natural log? This might be the first one that I've done like this. So right here, it's a base 3, so I can't use the log button on my calculator. So what I get to do, now this is dependent on your own calculator. If you have one of the color ones, which are probably the majority, then what you're going to do is you're going to do math, and then you hit alpha, which happens to really just be, if you scroll down, 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 it's A. So we do math, alpha, and then math again, because that's the A. And it pops up a logarithm where you can type in this logarithm exact. And so I'm typing that in. Yeah, I had the wrong answer written there. So let's talk about why I knew it was the wrong answer. I had over here on my scratch paper, I had an x equals 3.8. I don't know what I did, but I was just sitting there thinking in my head, I'm thinking 3 to the third would be a 27, and this is almost 3 to the fourth. There's no way that could be 6.5. So using some of that common sense to make sure your answers are correct is a good idea. All right, if you don't have a calculator that you can do math alpha math on, then you should be doing that change of base formula that I'm guessing you're familiar with. If you are using a calculator, you know. If not, you can Google that change of base formula. Okay, so now we quit notes at this stage, and I just had everybody find a partner and just start working through some problems at your own pace. So I'm not doing these next problems. I want you to do all the problems for the rest of your notes. This is not something you want to skip. You need to go through and see what your level of understanding is here on all of these problems. Work through them. When you are done with the rest of the notes for this, then come back and I'll have the answer key, but I'm not going through them. I'm just showing you, here's the answer. And if you got that answer, great. If you didn't, I will have the work for you to check your answer, but you really need to try this on your own. So go ahead and pause and get to work. Oh, okay, so here we go. I'm going through them, just showing you the answers. The work is there. If you agree, keep on going. If you disagree, pause and look and see where you got them wrong. Here's the next page. Okay, so this one, I actually showed two different ways that you might have done this one. Either one is totally fine. I feel like the left side's a lot easier, but if you instead thought to bring this 2 up as a power, that's good, but you got to make sure it goes on the 3 and the x so that that's a 9x squared. And then this is the last one, a little bit trickier. You had to do some FOIL here to get that figured out. And then you had to bring this over, and then you had to refoil it or refactor it. And it had an extraneous solution, which I hinted at right here. Remember that you can't take the log of a negative number. So when I got a 1 here and put it in, I would have been taking the natural log of a negative 1, and that would not have worked in the problem. That's a new thing, and anticipate that happening on your homework as we move forward. Always be checking when you're solving that you're never taking the log of a negative number. Okay, that's all we've got. Good luck.